Hello everyone. So I am Debasish Bhattacharya. I am assistant professor in SBIST college. So today I am going to discuss a problem on maxima and minima. So it is saying that the function fxy equal to x cube plus y cube minus 3x plus minus 12y plus 20. So we have a function. We have to calculate the maximum and minimum value of this function. So you know that to calculate maxima and minima, at first we have to calculate the first order derivative, the first order partial derivative of this function with respect to x. So this is our function. So x cube plus y cube. So if I do the partial derivative, so it will be 3x square, and the partial derivative of y cube with respect to x is 0 because y cube will be treated as constant. So that's why this will be 3x square. 3x square. After that, it will be minus of 3. Okay, there is no term containing x, so fx will be 3x square minus 3. So similarly, fy will be the partial derivative of f with respect to y. That means 3y square minus 12. So the second order partial derivative of fx will be f of xx. So it will be 6x. And second order of partial derivative of fy with respect to y, it will be 6y. Okay. Now we will calculate f of xy. That means we have fy. So f of xy will be, we have to take the derivative of 3y square with respect to x. Okay. So the derivative of fy with respect to x will be 0 because fy has no term containing x. So f of xy will be equal to 0. Okay. For maxima and minima, we know that fx is 0 and fy is 0. We have to take fx equal to 0 and fy equals to 0. So we will do fx equals to 0. Now, if I take fx equal to 0, I will have 3x square minus 3 equal to 0. That means I am writing it directly. So x square is equal to 1. So the solution will be x equal to plus minus 1. Okay. So similarly, fy equals to 0 will give that 3y square minus 12 equals to 0 and 3y square equal to 12. So y square equal to 4. That means y equal to plus minus. Okay. Now if x equal to 1, then what will be the value of y? Now if x equal to 1, the value of y will be. So the critical points are plus 1, plus 2, plus 1, minus 2, will be minus 1, plus 2, and minus 1, minus 2. Okay. So these are critical points. Critical point means that at these points the maxima can exist, minima can exist. Okay, it can exist, but it may be possible that the maxima or minima cannot exist, will not exist. So at 1, 2, now h of xy, we are defining h of xy is equal to f of xx, f of yy minus f of xy whole square. If this expression at some point, this expression is positive, then maxima or minima will exist. If this expression is negative, then maxima and minima will not exist. Now f of xy, now if I put this point 1, 2, h of 1, 2 will be fxx at 1, 2. So fxx, where is fxx? Fxx at x equal to 1. So it will be 6. Fyy at y equal to 2. Fyy at y equal to 2. It will be 12. Okay. Now fxy, where is fxy? Fxy is 0. So that's why fxy square, this will be equal to 0. So it is coming 72. Now 72 is greater 0. Now as 72 is greater 0 at 1 comma 2, maximum may be possible or minimum may be possible. Saddle point will not come at 1 comma 2. Okay. So now fxx at 1 comma 2, it will be, now fxx at 1 comma 2, it will be plus 6. So as fxx is greater than 0, so at this point minimum value exists. Okay, that means 1 comma 2 is a minimum of the function fx. So the other points are 1 comma minus 2. Now 1 comma minus 2 was a point. So if I calculate h of xy, so it will be, so fxx, h of xy was fxx. Now fxx was 6x. So that's why it will be 6 into f of yy. F of yy was 6y. So that's why it will be 6 into minus 2. Okay, minus fxy was identically 0, so it is 0. So it is minus 72. So as minus 72 is less than 0, so at this point there is no maximum minimum. So this point is a saddle point. Again at minus 1 comma 2, at minus 1 comma 2, h of xy equal to 6 into x, fx was 6x, so it will be 6 into minus 1 into fy was 6y, so it will be 6 into 2, and fxy was identically 0, so it will be minus 6 into, so it is negative. So whatever the value is negative. So as the value is negative, again this point is a saddle point. Okay, at minus 1 comma minus 2, it will be h of xy. You can see that these are here x coordinate and y coordinate both are negative, so it will give positive value. Okay, so that's why h of xy will be 6 into minus 1 into 6 into minus 2, and fxy was identically 0, so here the value will be positive. As the value is positive, this point is not a saddle point. Okay, so as this point is not a saddle point, we will calculate f of xx. Now f of xx was f of xx was where is f of xx? So 6x. So 6x. So here we will put the value 6 into minus 1. So it is minus 6. As fxx is negative, here less than 0. So at this point, minus 1 comma minus 2, fxy has maximum value. Okay. Now again we have another point, that is minus 1 comma, we have taken minus 1 comma plus 2 minus 1 comma minus 2. So we have done all the points. So the function is having a minimum value at 1 point, maximum value at 1 point, and 2 points are saddle.